Okay, this is the second part of the reaction mechanism videos, and just a little bit of a reminder of what was in the last video is the fact that a reaction mechanism, or reaction intermediate, which I abbreviate as RI, is first a product and second a reactant, and change colors here so it doesn't get confused. A catalyst is first a reactant and second a product. So this problem does what I said the last problem should do, which is what is the overall reaction, identify any catalyst and or reaction intermediates. So I'm first going to determine what my overall reaction is, and as in the last problem, we go through all of the reactants and check and see if any of them can be canceled out. Ce4 plus is over on the reactant side twice, but it's not over on the product side at all, so I'm going to add these when I write my overall reaction. Okay, I have a manganese 2 plus here and a manganese 2 plus there. There's one of each, so I'm going to cancel those out by drawing a line through them. I already talked about the Ce4 plus. Mn3 plus is here and there. Tl plus doesn't exist anywhere else. Mnn4 plus exists here and here. So to write the overall reaction, once I've canceled out everything, is to basically write down what hasn't been canceled out. And if you remember, the other thing is that if they're on the same side, they add. If they're on opposite sides, they subtract. So my overall reaction is going to be 2Ce4 plus Tl plus goes to form 2Ce3 pluses plus a Tl3 plus. Okay, so that's my overall reaction. Now I'm going to go through for every one of these that I identified here. I want to identify them as either being a catalyst or a reaction intermediate. So I have manganese 2 plus, I have manganese 3 plus, and I have manganese 4 plus. So what I want to look at is this and find the corresponding one. Okay, the highest or the earliest is which one? It's a reactant here, and it is a product there, so that's going to make this one a catalyst. Okay, I look at my manganese 3 plus, it's here and it's here. Okay, so the earliest one is the product, and the second or the latest one is a reactant. So therefore that's a reaction intermediate. And for the last one, manganese 4 plus, it's here and it's here. So the earliest place it appears is manganese 4 plus, and the latest place that it appears is a reactant, so that also makes it a reaction intermediate. And that's all you have to do for this problem. We got one more. I suggest stopping and doing this on your own first, and then going back and doing it following to see if you got the right answer. Okay. So, again, I want the overall reaction, so I'm going to go through here. I have O3 here, and O3 doesn't exist over here. I have NO here, and I have NO there, so I'm going to cross those out. I have NO2 here and here, and I don't have just O. So my overall reaction is O3 plus O goes to form, and these two are on the same side, so they have to add to O2. So this is the decomposition of ozone by an oxygen molecule. Okay, and again, for everything that I crossed out, which is two of them, I have NO and NO2. Okay, I want to identify if it's a catalyst or reaction intermediate. So looking at NO, it's here and it's here. So the earliest that it is, or the first that it is, it's a reactant, and then it's a product. So this is a catalyst. And the second one, NO2, it's here and it's here. In the top or earliest, it's a product, and then it's a reactant, so it is a reaction intermediate. And that is the end of reaction mechanisms.